Hello once again. Today we will set up the vehicle network. Uh, so in order to start, what exactly you need to do is you these are the basically system overview. What basically we'll set the system in a way something like this, where we would have two ESP32 controller. You make use Arduino. So basically this one would have a logic of AEB controller. So what exactly it will do is if it detects some of the traffic sign from the cam through the camera. Here we will not use camera, we'll just simulate through serial bus. Okay, yeah. So what exactly you imagine if your vehicle is detecting some of the sign, and based on that it will look into what vehicle speed it is running, and if it is getting the input from basically this traffic sign, this will be detected by these ECUs. This will collect the data from the camera, and it will send it on the bus. ESP32 ECU1 will take this input, and here we have AEB logic, AEB control logic. It will apply the braking based on the logic written inside it. So what exact, and then we would have the CAN modules. I'll tell you why we have a CAN modules. We have a Raspberry Pi, we have OTA manager, CAN gateway. So we'll see what exactly these all things are there, and how basically we'll update through the cloud, and we'll remotely control all this vehicle. Okay, so this is just a system overview, high level system overview, a basic simple one. Will As we progress, will enhance this diagram, will give you low level design of all this stuff, but just to understand, this would be basically we are going to achieve. Okay, now what we need at the end. So we need for this to realize what all hardware we required is, we use central compute. For the central compute we need Raspberry Pi, and you can use 4 or 5 if you have already the latest one, you can go with the Raspberry Pi 5, or if you have Raspberry Pi 4, then you can also use that one. I hope this yeah, you can also go whatever you have, but these are basically, as I had with me Raspberry Pi 4, I went with this one. So you need some memory card. So um, you can use 32 GB SD card. So yeah, and then as Raspberry Pi will come, now you need OS on top of it. You need Raspberry Pi OS, and I'll share you the guide how basically install on your Raspberry Pi board, and how basically you'll use it. Other things you required, these are two ECUs, ECU1, ECU2. You can use ESP32 dev kit. You can buy it from the local market, local electronics market, or you can try on Amazon or Flipkart. There also you can get it. Yeah. Third is MCP 2515 one CAN modules. You require 3 units. So basically, why we need is, like, Raspberry Pi does not come inbuilt with CAN interface. So you would have the SPI, and if you have the SPI, you can use MCP 2515. You will just enable this, and then you will start using MCP 251 is a CAN module. Through SPI will connect with the Raspberry Pi, and will show you how basically you can do the configurations there. And definitely for this all board, you would need some power power supply and some wiring harness that you please arrange it. Basically 5 volt power supply, USB power supply also it work for Raspberry Pi. And yeah, you can just just see the specifications of your board, and how much voltage it is required by through USB or something. You can basically provide it to the board. So these are the basics hardware that you required in order to basically, how to say, in order to basically set up the vehicle network. Yeah. So let's understand what exactly in the, okay, these are the hardwares are required. Now would be wiring harness. So basically the connections you will make. So basically this guide will tell you exactly what you need to do is you would have basically Raspberry Pi and MCP251 wiring connections shown over here. So as I mentioned, so Raspberry Pi will not come in built with uh, CAN interface. So you have the SPI on this board, and what you do is with this SPI you can use MCP2515 CAN module, and you basically enable this communication for the SPI on this Raspberry Pi, and you are very much able to achieve the CAN modules, uh, CAN communications on your Raspberry Pi. Yeah. So how basically you will do is you have to make a connection in a way that you would have VCC pin over here in this port MCP2515. You connect with your 5 volt pin 3.3 minimum which is required. You just see that okay, this is the pin number 1 in the Raspberry Pi board. You just connect it over there. You would have the ground at pin number 6 over here, and here you have a ground. You connect it with this 2 wire, and then you would have chip select over here. So basically where you have the pin number 24 in this, and you have to select with CS over here. Similarly, you have mentioned over all the pin on the MCP251 side, and here you have with the Raspberry Pi, where you would have basically MISO, MOSI, SCLK, all these six connections that you have to make it how to say connected both the controllers with the wirings. Yeah, make sure that these wirings are not loose. Yeah, try to use breadboard, or if you have basically some sort of connector you have prepared, then you can use that one also. Right, so this is the connections in you can, yeah, basically use this, and you can basically do the connections between these two MCP and Raspberry Pi. Similarly, you would have two SP32 boards, and you have to connect in this both the controller in a similar fashions with MCP2515. So this is the pin configuration. You would have MCP2515 in the left side and ESP32 in the right side. So what exactly you need to do is you would have the VCC pin ground. Similarly, you would have VCC and ground pin over there, and mm, so don't be confused with this diagram. It might be saying wrong because the red pin from the VCC is going to the TX pin. This is incorrect. Please follow this one, this diagram. This basically pin configuration. This is just for representation. I have basically took the source from internet and then basically pasted over here. Okay, and what exactly you need to do is you have to connect your CS pin with the GPIO 5, SO pin GPIO with 910, SI with GPIO 23, SCK with GPIO 18, your basically PCC with the 5 volt, ground with the ground volt, and similarly you follow this basically, the pin configuration. Do not get confused with this pin how basically it is on over here. Okay. Um, yeah. All right. So these are the basically basic configuration. You have to basic wiring harness you have to prepare. And what exactly some point you have to notice, like even though if you are connecting all this pin correctly, some things you need to take a note, which is very important. Basically, it's a quite common ground for all these devices. So what you do is you basically make one uh, common ground coming from all this this controllers, either MCP2515. There are three numbers of MCP2515 board, right? And also there are two ESP32 boards. Please connect your all basically can not can do. Basically, you have to connect all ground together. It's required common ground, okay, because voltage reference should be matched. Also, you have to connect all your CAN high of all three MCP modules together. Also, you have to make a CAN low of all three modules of MCP251 together. Also, you have to make a note that okay, if your MCP2515 by default it is not coming with the 120 ohm resistors, then you have to basically bring it from the market and connect it to terminate the network, because 120 ohm resistors required for termination in the CAN protocol, because you have a guided guided signal that need required terminations. Okay, otherwise you will lose the communications. So please make sure that you have 120 ohm resistors available in the board. How basically you'll find it? If you go to the MCP2515 board, and if you find over here, these are some resistors, and there are J1 or J2 they have mentioned, they will clearly mention, okay, this is 120 ohm. If you go to the spreadsheet, you will find the information of MCP2515. So you go into this MCP2515, 120 ohm. So I go to this one, and if you come over here, and you can see over here it is 120 ohm resistors, it is there. You may, and you may need a jumper to sort this two pin. Yeah, so it is there, it is saying yes, resistors is there, 120 ohm resistor is there, but in order to use in this J1, you have to basically sort it up, otherwise it will not work. It is the it is in the, how to say, the 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 electric circuit is open, and you have to use some jumper in order to sort it, in order to make a closed network, right? So in order to do that, you need, if it is available, some of the board I have seen there, MCP251 does not contains 120 ohm resistor. In that case, you have CAN high and CAN low. Bring the pin out in the breadboard and then do the termination of 120 ohm with this two. So that is also sometimes people does, because CAN high CAN low is there, and if it is not able, you just basically sort it with the external 120 ohm resistors. Yeah, but these are something you have to do in order to basically see the communication is up and running. We'll verify how basically we will do it, but just make it short. What exactly we need to do is, let me recap again. So in order to start, we need this many of hardware. We need Raspberry Pi. You can use any latest or Pi 4 I had, so I used Pi 4. Okay, you need some of the memory card, because your basically this Raspberry Pi does not come with the, how to say, storage, so you have to bring some external storage here. And then you would have you need to install Raspberry Pi OS into this, and then you need ESP32 edge ECUs. Basically you can buy it from market. You need some MCP2515 CAN modules, because Raspberry Pi does not have a CAN communications pins available on this. It is been built, it is not there. Through SPI will do it. And also sometimes you need 120 ohm resistors, you can buy it from outside, but yes, um, sometimes this, on the board it is there, so you have to check. If it is there, you don't need 120 ohm terminator resistor. Basically you need some power supply. Once it is there, please connect according to the wiring diagram shown over here for both the ECUs, all three ECUs basically with the MCP. With the Raspberry Pi is one set, another set is with two ESP32. You have to connect MCP2515 in the same pin configuration way. Yeah. So once you are done, so the physical hardware setup is up, at least on the ESP32 MCP side. Still you have to do some configuration, because I told you by default Raspberry Pi is not basically providing you CAN interface. And as you are using SPI, by default SPI would also be disabled. I have to enable SPI in order to start the communication with MCP251 CAN modules. So we will see how basically we'll do that. Yeah. Before that, as you have this Raspberry Pi board, it is just a mini computer. So you need to log in on this computer. How will you do that? That is the first question. Or if you are already using basically how will you, this is the first once if you are already using, so you must be knowing okay how basically you can log in over here. But the first time user, you need to do some basic configurations in order to start working with Raspberry Pi 4. Okay, so what is this? So I have prepared guide. Basically you have to follow it. So this is the guide you can follow and set up this Raspberry Pi basically basic initial configuration in order to start and log into this basically board. Yeah, but I'll guide you also. What exactly you need to do is you basically go to the Raspberry Pi as OS installer. So this is the Raspberry Pi OS download, and then what you go based on what operating system you have, download it for Windows, Mac OS, or whatever it is, and do the simple installations. Once you are you have installed, it will be showing something like Raspberry Pi imager. Launch this Raspberry Pi imager, and what exactly you have to do is you have to go over here, you have to go and select your board. So as I told you, like it might be Pi 4, Pi 5. I had Pi 4, I'll select Pi 4. Then I have to see, I have to basically I have to select the operating system that I wanted to have in my on my Raspberry Pi board. So I will select the Raspberry Pi OS 64-bit. I'll go to the next. Then I would have the storage attached to it. Basically, the storage you will connect to your machine, and then there you will basically flash it. This all things over there. Okay, and then you select the storage, and you have to make some customization configurations over here. For example, if you are using first time, it might not be knowing what is your host name for this you wanted to give for this controllers. Second thing is what is your localizations, what basically you would be connecting to Wi-Fi. Raspberry Pi would basically have the prompting you need basically to log in you need the private IP. What you can do is you just type 192.168.1.1, and once you do it, it will prompt you, and you just type admin, and you just type admin as a password, and you try to log in. It will open a page something like this. Yeah, something like this. You will find your all LAN devices information over here. You can go into this and you can find whatever the with the your host name that you have given, you can find it what is the devices you have. If you are not finding over here, you can go further into this information. There is detailed information available, the client information side, and you will find okay, you have the host name over here, something like your pi name, that your host name you have given, and this is the IP address for your devices there, for example, right? So that you can find once you log in here. So once you do the login, you would be able to basically log into the Raspberry Pi. Yeah. So just a second, let me log into this. Now you can see I log into my devices. Yeah. So this is my device and this is my login username basically. So yeah, so once I am done, the first step I'll do is okay, so now I am logged into to this. Just think of this just a mini machine for you. Okay, now you need all these things, right? So in order to have this communication, you need to enable some of the configurations on this particular machine. Yeah, and you have to see the communications, basic communication, in order to start the real project. So that we will do all this step over here. Just give me a few seconds. Just I'll explain you how basically you can do that, and this all are available in this guide if you follow it. Yeah, so now is first is in order to basically start, first you have to run this command sudo apt update. You just go over there and sudo apt update. So you have to do it. So it will update all the packages for you. Once you are updated, basically I'll just explain you all the steps that you have to do. Basically, there are already some of the package already I have installed it. I don't want it to again execute the same thing on the machine. But yeah, just to explain you this is the first way. Similarly, you can basically you can update all your packages. So just follow across this guide and then you will find the solution. So next is, once you are done with the update, what you have to do is, as we have to yeah, we have to enable the can. So we need the can utilities packages. So yes, just to explain you what is this apt is. Apt is just is a package manager. Similarly, you would have in Python, you have a pip. Similarly, apt over here is will basically pull or update the packages that we are going to use in this. This is for the Linux Ubuntu. We are using this operating system that we have installed for Raspberry Pi's Ubuntu, and then for this we would have apt as a package manager. That's it. We are using apt. So we first updated all the packages, and then we are installing can utilities. What exactly this can utility will do is, it will have basically um, it will capture and display all frame received on the interface. That is the most important thing that we required. That is basically we have expectation from the can modules. So we have to enable this. Okay, this will install the once you install these packages, it will allow you to basically receive or display the captured frames basically on the interface that it has. Also, it will able to inject can signal through can send command. You would have the can generation. It will generate random traffic for a stress testing on the bus. This package will give you, with this method you can do that. Can bus load. You can also, you see that the percentage bus load on basically on your bus with this method basically. Yeah, so we'll see once we work extensively on the project side, but I right now we don't need it. Also, for few of the things, basically, yes, we need in order to display, in order to send some signals onto into the bus, we would require, that's the reason we are installing this. You will able to do the CAN communications with this too. The answer is no, because I explained in the beginning is the CAN modules. This Raspberry Pi does not come in built capabilities of CAN. So, and you are using MCP2515 as a CAN modules. You will connect through SPI, right? But by default, this Raspberry Pi has SPI interface disabled. Okay. So what exactly we have to do is, we have to enable SPI interface. Okay. So you have to run this command. You have to do raspi configuration. You run sudo raspi configuration. Then once you run this command, it will open the interfaces. And if you let me show you a bit. Raspi. Just a sec. So okay, yeah. So basically, if you see, it will ask you for interfaces options. Interface option, you go down and select interface option, and then basically do the configuration that you wanted to do. That is mentioned over here. Yeah, just let me show you again here. Yeah, so this is your configuration. So you complete your configuration, and then once it is done, please disable it. Yeah, just let me and finish. I'll not select anything. Yeah, so it is already configuration is done, so I'm not going to change it over there. Yeah, once it is done, do the reboot. So once you are doing the reboot, you have to again connect through SSH, the same command that we have seen, SSH username, and basically at the rate your basically private IP, and then you basically not username, SSH, your device name at the rate your private IP, and then you have to give your password, all this stuff over there. Yeah. So what is next? So yeah, yeah. So once, sorry, I just this is my bad. Like basically, how basically we'll do the login is simply SSH username at the rate private IP, and then you give the password. It will basically log into it again to the terminal. So now basically once you have done the Raspberry configuration, this will enable SPI. What you have to do, I explain you, is like go to this option, go to the reboot, and you have to basically update this command over there. Okay, this basically this two line over there, you have to update this 2 point where it will tell you that SPI on channel 0 or channel 1 it is enabled. Both you can basically enable it. Okay, yeah. So that is something you have to do is, yeah, this is something once you run. Okay, once you have this executed, you enable this interface option. If you look into ls command, but it is saying ls dev, just a second, ls dev spi, it will tell you this is enabled over here. Yeah, it is expected to be here. In your case it might be dev 0 or dev 1, where you had connected the basically your interfaces. Now, so now what you have done is you have enabled SPI into your Raspberry Pi. So now we expect like, okay, your MCP can talk to Raspberry Pi through SPI. That is fine. But in order to have to basically this Raspberry Pi to connect with MCP, you need another driver, and that basically we called it MCP 251 driver overlay. So what exactly you do is you just you run this command, you do the configuration, okay, in the firmware, and update this 3 line at the bottom. Okay, and what exactly it is doing, it is saying SPI is on, and you are basically setting the oscillator values. So basically if you go up, you will find over here oscillator in your MCP modules. Sometime it is 16 megahertz or sometime it is 8 megahertz. So based on that you have to update over here. So right now it is 8, you have to update over 8 megahertz here. You have to mention some interrupt here, and then you have to basically give this input. This 3 line basically you have to update it in your config file for the firmware configurations. Okay, so what exactly it is doing, we have basically explained over here. One is the DT param SPI on is basically enabling your SPI in the device tree. Okay, and then you have DT overlay relay. Okay, overlay DT overlay, and this is saying you a CAN 0, and basically it is what it is doing, load the MCP 2515 driver. It is loading the MCP 215 drivers basically to this particular COM interface where the SPI is available in Raspberry Pi, and it is also mentioning, okay, you would have the oscillator of 16 megahertz, but in your case if it is 8 megahertz, you change it to 8 megahertz, must match the crystal frequency on your record board. Okay, it is also telling the same thing, that you please make sure that your board is also 16 megahertz oscillator is. If it is not, please change it to 8. Yeah, and you would have the interrupt 25 maps with the MCP 2515 interrupt. So we have the interrupt pin over here, if you see. So this is also we need to give the interrupt in order to basically do the control. Yeah, so this is one thing. Yeah, so this all configuration you have to do it in the Raspberry Pi. Yeah, so once you are done once you are done with all these configurations, firmware configurations, basically device driver update, your Raspberry Pi SPI configuration enabling because MCP required it. So once you are done with all this stuff, then you can simply see the CAN communications. But as of now, you will not see all the data broadcasting into it because obviously uh, your local network is not basically your is not your basically ESP32 is not placed. You will not see the data floating in the CAN network, but at least if you see the CAN dump any, then you will expect this data later on once you have this information. Your configuration is ready. Your ES both the ESP32 controller are flashed with the logic with the TXRX ID. You will get all this information over there. But as of now, you think of it is not basically how to say you will not get the data something like this on the bus at the moment at least. Okay, so what exactly you can expect, how basically you will verify that yes, your configuration, every configuration is done, your CAN network is up, and it is basically ready to receive or send any of the message on the bus. How will you do that? So in order to do that, give me a second. I have let Yeah, so basically, as I explained you would not be able to see this CAN message on the network because you do not have basically um, flash your local ECUs for the EB and transmission control, traffic sign memory, sorry. So what exactly you need to do is just in order to verify, you just run this command. Let me search it. Because this is the Linux interface, so it should be treated something like that. Can zero. Okay, just para links and can zero. Yeah, this is basically command, but yes, I'll just let me find from my own reference. Let me yes. I'll just run this command simply. Yeah, sudo IP link can 0 type can bitrate 5000. So basically what I'm trying to say over here is like as I told you, CAN interface is managed like a network interface. So before communication can begin, we have to configure the CAN controller with the correct bus bit rate. For example, 500 kps over here. Okay, and we have to bring the interface in the upstate. And once we have the network in upstate, you can see that whether your basic interface is up or not. That basically we have one more command, through that we will do it. If I run this command, it will show me it is busy because as already shown you that our local network is up, it is showing the communication is floating. So maybe I'll just run this command. Just a second. If you see over here, okay, what happened? It is why it is down. Yeah, so it is asking me again a password. So it is saying device is already busy, but in your case, you will find some information. and this information would be something like it is showing it will basically start the basically network, and if you just write this command IP, I guess details, yeah, so basically okay, this is asking IP detail. Then what I have to use is IP detail. Uh, yes, IP detail, and then we have to use options object. Yes, so IP details, and if I say link, so as I have a can 0, so I'll do the can 0. It will tell me that okay, my network is up. Yeah, so you should also see this kind of information in your basically once you run this command, it means your network setup is completely correct. Now, basically, at least from the Raspberry Pi and MCP 2515 side, your communication is enabled. You, if any of the messages on this buses, if it is coming, you will definitely receive over here on the bus. Yeah.